Everybody had the time to get settled in. My name is Alice Lovegrove. I'm the U.S. National Director for the Acoustics, Vibration, and Air Quality Group. I've been doing air quality work for over 30 years, and we're going to be presenting about the Ramona Gardens project, an interesting twist on how we do air quality, and I'd like to introduce you to my co-presenter, Edward Tadros.
Hi, I'm Edward Tadros. Been with the National Air Quality and Noise Group here in the United States. I work with Alice. We've been working together for 15 years. We're both in the New York City office, and we're actually here together in the office today, which is nice after all this pandemic craziness. So, yeah, thanks for joining us today.
So let's get right into the Ramona Gardens Natural Park project that we worked on. What we'd like to go over is some of the air pollution issues, what made this a unique area that had some very unique characteristics, explaining the existing conditions in the area, and then going into some of our solutions about how we could potentially help the air quality and create a park for the citizens of the Ramona Park area. Go into some of the key innovations that we were able to bring to the project and some of the things we learned along the way. There will be questions and answer session opportunities at the end of the discussion, so if you think of anything, please feel free to put the questions in the question box that you'll see on the screen, or we will open it up to questions at the end of the presentation. Before I go any further, Eddie and I are the ones who are presenting this project, but as with every good project that comes out of WSP, it was truly a team effort. Tim Kidman in our San Diego office was the practice leader who brought us on board to help with this. Kamini Prasad and Nagar Khalili, Kamini in our New York office and Nagar in our Sacramento office, did a tremendous amount of research, brought together all the data so that we could make a good presentation to the clients and to really give some good potential solutions to the park. And I would be greatly remiss not to also mention Esther Feldman, who had the vision. She is with Community Conservation Solutions with this particular project, who had the vision to be able to see that we could be able to help and bring some innovative ideas, and really was the stimulus to really get this project going. So I have to really tip my hat to Esther. She was wonderful to work with, and we were very fortunate to be able to work with her. With that said, let's get into the project. So Ramona Gardens is located in Los Angeles, California. As you can see on the slide, it is right next to major freeways with not a lot of barriers between that. There's also a rail line. I'm not sure if you can see it, but right over on the side is a diesel rail line, a high-density freeway, and a relatively small population with a lot of children located near there. You can see some of the ADTs as the average annual daily traffic on the roadways that are near Ramona Gardens. They're really high. Usually anything over 140,000 average annual daily traffic is what the U.S. Federal Highway Administration considers to be significant. And you can see on these numbers that they're quite a bit higher than what the level of concern would be for FHWA. When you have that high level of traffic, you start seeing some health impacts from the air quality, from the tailpipe emissions, from the road dust that gets generated. You see higher levels of asthma, reduced lung function, cardiovascular disease, and premature death. All these aspects this community is feeling the effects of. Ramona Gardens also has some just environmental factors against it because of its landscape. California has this neat program where they show you the urban heat island effect, which generally, the effect is that it raises the temperature in areas. And you can see from this graphic that when the areas that are near the shore get a little bit of the cooling breeze in, and then as you go further away from it, that effect diminishes, and you start seeing the temperature rising, mainly because there's a lot of asphalt, not a lot of greenery, they're not getting the cooling winds from the ocean. So Ramona Gardens is the temperature due to the urban heat island effect is 4.4 degrees Fahrenheit, about 2 degrees Celsius, higher than other areas in the state because of that. And we mention this all because it combines to show why the air quality is such an issue for this particular area. One of the things that we also looked at in this area is, so we know it's around a lot of roadways. We know it has the impact of the urban heat island effect, but which way do the winds blow? Are the winds blowing the exhaust emissions from the roadways into the community? And we did a little windrows analysis, and indeed they are. So this community is kind of getting the worst of the worst. The pollution blown to them from the roadways, it's extra hot, and it's right near the sources. So these were all important factors to say, what's going on here and what can we do about it. One of the things that we're doing as we do more studies is a lot of times we look at the monitored air quality data to see what the impacts are in the area. And the air quality data for this particular area certainly was showing that ozone levels were high, and that some of the PM levels were high. But, it's very hard to take a table like this and explain it to the public in any meaningful way. The numbers seem, it's just a bunch of numbers. So we really tried to present our argument about why this area needed some extra help by using the air quality index, which is a little bit, I'm sure some of you are familiar with it. If not, I'll just explain it quickly, is that the air quality index takes all the different standards that we have and puts them on a scale. So basically, 100, and this is just general, if you're at 100, you're basically at the air quality standard. So 0 to 50, you're usually about half the standard of that particular pollutant. Things seem to be okay. As you get 51 to 100, you're approaching it, and sensitive people can start feeling the effect. And as you can see from the chart, it goes up from there based on the monitor data. So it's a nice way to really present the data to an audience that may not know micrograms per cubic meter to parts per billion, parts per million. It kind of equalizes the playing field to explain that information. So we use the air quality index to present the data. So rather than have, this crazy table, we decided to present the data this way graphically, so the residents of the community could understand what their daily measurements were showing and what ranges they were in to the air quality index. And it's something that we're starting to use on other projects now because it gives a nice visual rather than just looking at numbers and some odd kind of units associated with those numbers. One of the other issues, and there's a real focus on in the U.S., is environmental justice and making sure that certain communities don't take the brunt of any type of development on the environmental side. So California has this CalEnviro screen model that takes into account not only the pollutant burdens and the exposures of the population, but also the characteristics of the population. If it's a poorer neighborhood, if they're not getting to medical facilities, if there's a lack of health insurance, things like that, all fit into this equation where they take the actual emissions that are happening and the exposure and the characteristics of the community and come up with what they call a CalEnviro screen score. And it really, again, the point is to equalize the playing field. It really helps to equalize the playing field to see how different communities are affected, not only by the actual monitored levels, but on the characteristics of the community. So Ramona Gardens went through, the state put Ramona Gardens area through this process. and it came out as in the top 95 to 100% percentile of communities affected by pollution. And you can see here, this is, the grading with the gradients of the color to show that it really is being impacted by so many of the pollution sources in that area and because of the population in the area. California also did a study, the Multiple Air Toxics Exposure Study, the MATE study. So they evaluated all the air toxics in the area and predicted a risk for people to have additional cancers due to that. And 90% of those risks have been associated with emissions from mobile sources. And like we said earlier in the conversation, the Ramona Gardens area has those freeways around it, so it really is getting the impact of those emission sources. So taking that information, California also, puts this air toxic risk study together, and if you see in this purple area, that's right where the Ramona Gardens falls. It's in all those transportation corridors. It has a really high air toxic risk associated with it. So this was an area that was really ripe for some good solutions to come about. How can we reduce the emissions that were coming from the roadways onto the community, and what could we do about the urban island heat effects that they were experiencing? So I'm going to switch over. Eddie is going to take it from here about the potential solutions we had to this situation.
Thanks, Alice. So everything Alice went through kind of makes the case for the project area and Ramona Gardens for us trying to do something to help them with this natural park to reduce air pollution from the highway and from the railway. So there's different solutions for reducing emissions, and one is to reduce emissions at the source, like when you switch to electric vehicles, just building buildings away from highways or indoor filtration systems. Now with this project, it's an outdoor project at a park. We had no control over the first three variables. So we focused on, the only thing we could do was the design of the park itself. So one thing we looked at was the effect of traditional noise barriers on air pollution. So they were looking to put in noise barriers anyway. So we did a little bit of research on that. So particulate matter, which mostly comes from diesel fumes, and it's, when you're on a highway and you see the side of it that's, very dark black soot, that's your particulate matter. So we did some research and we realized that barriers can be effective at cutting particulate matter based on the wind direction, which we already showed would help because it's the way it's blowing. That particulate matter gets pushed over the top of the barrier and is dispersed. And the higher the barrier is, the better it is at dispersing pollutants. A little table at the bottom is from the Sacramento guidance about how high a barrier you would need to disperse pollutants. 13 to 20 feet high, it's about 3 to 4 meters. And that you would want to go beyond the area of concern, like wrap a barrier around the community a little bit to protect it from air pollutants. There are other types of barriers besides just traditional concrete barriers. There's photocatalytic barriers, which use sunlight and they remove more NOx from the emissions. And there's also some newer technology, Smog Stop, which is creating these barriers that can actively remove NOx from the roadway. They did a test barrier outside of Toronto in Canada, and they're building one in London. So it's kind of a new technology, but we did some research and contacted the company, and they're working with the university up in Canada. So they gave us some information on, how effective their barrier is at removing additional pollutants. So we looked into that as well. And then there's also Vegetation Solutions, which, natural barriers, where you'd have a solid noise barrier and vegetation behind or in front. In this case, it would be behind on the park side. So we did some research on that. California had some good guidance. Sacramento, the table at the bottom, Air District, about certain characteristics that would be best for the vegetative barrier. not having much spaces in between, using native species with broad leaves, and so we did a bit of research on that to come up with some recommendations. And as I stated before, this shows you some of these images of what's effective and what's ineffective. It's kind of a bit of common sense too, when you have a thick barrier of vegetation, and if you combine that with a noise barrier, you get even more benefits. So our final recommendations to the project team were, number one, to use a dual barrier and vegetation system to reduce the air pollutants. And number two, we said maybe consider, one of these active noise barriers. They're pricier, especially the smog stop. It can be like 3 times the cost of a regular noise barrier. So the project decided to go with our first recommendation, and the landscape architects and the engineers and everybody went through everything we recommended and researched to kind of build in some of these things to the park. As you'll see on the bottom in the image, it's showing the freeway to the left of the train line. And, so we discussed putting a barrier in with a berm so the vegetation could climb up the berm and be higher. And they looked at which species to use and things like that to help disperse the pollutants from the roadway. There was a bit of community outreach too. Neg, on our staff out in Sacramento, went down, and Tim in San Diego, he went up to LA, and they assisted the project team. They gave a presentation on air quality. Our client, Legacy LA, which is a community youth-led community organization, they're the main client on this. They asked some of the students and parents to carry some air pollution monitors around and to discuss their findings at the meeting, where they did find elevated particulate matter levels as they were closer to the highway. And there were staff present from some of the agencies that were funding the study, the California Air Resources Board and the State Coastal Conservancy. So the project design is complete. It's awaiting construction funding. The WSP is not involved in the actual construction of this. So we'll monitor it and see, hopefully that comes soon. And there's a nice little quote from Lou Calanch from Legacy LA about how WSP helped. We really made the case for doing this. We did check off a bunch of sustainability development goals, as you can see here, numbers 3 and 9 and 10. Reduced inequality, good health and well-being, life on land. So that was nice. Now, some key innovations as part of this project, as Alice described earlier, the use of the air quality index to depict air quality data in simple layman's terms. The use of these advanced California models, the environmental screen and the MATES, those are great. They really helped us understand things. And the California is very progressive when it comes to these things. We're starting to see it in other states in the U.S., and we're starting to see other projects kind of look for the same kind of information. And the use of barriers in natural vegetation to mitigate air quality impacts. And some of our key takeaways, as Alice described earlier, the urban heat island effect, how it greatly exacerbates the effect of smog. The research showing the extent of disadvantaged communities near major transportation corridors, which is a big issue here in the U.S., and the current administration is trying to build that into the next infrastructure packages that we really have to take equity and environmental justice even more seriously. And there's many cities even looking to remove transportation corridors that were built decades ago in disadvantaged communities. And so we're seeing this become more and more of an issue everywhere. And the effectiveness of barriers and vegetation, how it depends on different variables, species, placement, prevailing winds, and the local geography. So that's it for now. We thank you so much for joining us. We're open to questions. You can send them in the in the chat box.
In the chat, yeah.
Yes, thank you. Thank you, Alice and Eddie, for a fantastic presentation. So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download a PDF version of the presentation from the handout box on the dashboard. I will start with the first question. How was the project received by the local community?
Very positively right now. I think the community outreach was very successful, and the fact that they were receiving some attention given the health risks and their experiences with these really big pollution sources, that they saw this as a positive step forward, not only helping with the public health aspect of it, but creating a community area that people could congregate in and enjoy.
Yeah.
Thank you. Next question is, how effective are active noise barrier in removing pollution?
So it depends. The photocatalytic barriers, they work with sunlight. It kind of helps remove the NOx through some chemical reactions. So that depends a lot on the amount of sun, the placement of the barrier. I'd say typically maybe a 10 to 20% reduction. And these smog stop barriers, which they're just coming out, they could be 50 to 90% reductions depending on different factors. They're not dependent on sunlight. There's not, they did some research in some labs up in Canada. I forget the exact university, but it was very promising. And the test barrier in outside of Toronto is showing some good field results. So I think they're building a bigger one in London. We'll get a little more information on that, and kind of track it. I think see how it goes.
Thank you. Can this approach be applied to other countries, cities, and projects?
Yeah, I think it can. I think one of the things that Eddie and I and the team really liked about this particular analysis was that it wasn't a one-stop solution. We looked at the wind direction, we looked at the elements, we looked at the community to make sure that we gave them a unique solution for their unique situation. So absolutely, it can be applied to other areas with that caveat that you look at the specific requirements. If you're putting a noise barrier, but the wind doesn't blow the pollution that way, then that may not be an effective solution to the issue. You might have to look at some other elements to resolve the issue that particular community could be experiencing. So absolutely applicable, but make sure it's tailored to your specific needs.
Fantastic, thank you. We don't have additional questions, so it looks like we're at the end of our webinar session. So please feel free to follow up directly with Eddie and Alice via the contact details shown on the screen. And I would like to thank all attendees for joining today. Thank you very much for your time, and thank you, team, for a fantastic presentation.
Thank you very much. Thanks for having us,
and
thanks for listening in, everyone.
Thank you very much.